Hello everyone, welcome to another video. On the board, we have two questions. The first one is for us to show that log to base 4 of 3 is equals to log to base 2 of radical 3. Hence, or otherwise, solve the simultaneous equation. So we have the first equation, which is 2 log to base 2 of y equals log to base 4 of 3 plus log to base 2 of x. 3 exponent y is equals to 9 exponent x, and that's equation 2, given that x and y are positive. So for the first question, okay, for the first question, to show that log to base 4 of 3 is equals to log to base 2 of radical 3, I'm going to use change of base property of logarithms. That is, use the change of base property of logarithms. Use the change of base property of logarithms. That is, if we have log to base a of b, this will be equals to log to base c of b divided by log to base c of a. So which means log to base 4 of 3 will be equals to log to base 2 of 3. That is when I change the base to 2, okay? So we have log to base 2 of 3 divided by log to base 2 of 4. And this will be equals to, this is log to base 2 of 3 over log to base 2 of 2 raised to the power of 2. And that's still what? 4. Okay, now I'll bring this power here to become the multiplier of log to base 2 of 2. Okay, that is, I'm going to transpose the power. So which means this will be log to base 2 of 3 over 2 log to base 2 of 2. Now, also, one of the properties of logarithms is that when we have log to base a of a, this will be equals to 1, okay? So if we have the statement that log to base a of a is equals to 1, so it means that log to base 2 of 2 will be what? 1. And this will be log to base 2 of 3 divided by 2. And this is same thing as 1/2 of log to base 2 of 3. Now I'm going to bring this multiplier, I'm going to bring it here to become the power of 3, so that we can have 1/2 of log to base 2 of 3 to be equals to log to base 2 of 3 raised to the 1/2. Now, when the exponent is 1/2, okay, that means we can write that to be the square root of the base, okay, and that will be, so which means that this will be equals to, this is same thing as log to base 2 of radical 3. So therefore, log to base 4 of 3 is equals to log to base 2 of radical 3, okay? Okay, so the second question, okay, is to solve for the positive values of x and y. We are given the equations, we are given the first equation, that's equation 1. Equation 1 is given to be 2 log to base 2 of y equals to log to base 4 of 3 plus log to base 2 of x. That's the first equation. Then we have equation 2. Equation 2 is 3 exponent y equals to 9 exponent x. Okay, now let me start with equation 1. Now, I can write log to base 4 of 3 to be log to base 2 of 3. Okay, that will be the first thing that I will do. Okay, so I can say that from equation 1, okay, first I'm going to make this multiplier become the power of the argument, which is y, okay, and that will be y raised to the power of 2 in the first equation. So we have that this will be log to base 2 of y squared equals to, so this is same thing as 1 half of log to base 2 of 3 plus log to base 2 of x. Now, it is 1 half because we have it here that 1 half of log to base 2 of 3 is equals to log to base 2 of 3 exponent 1 half, which is same as log to base 2 of radical 3. Okay, so in this case, still dealing with equation 1. Okay, so now let me multiply through this equation by 2, so that this will be 2 log to base 2 of y squared will be equals to 2 multiplied by 1 half of log to base 2 of 3. I just want to use another method, okay? Plus 2 multiplied by log to base 2 of x. Now, this 2 will cancel this 2. Then again, I'm going to bring this power, I'm going to bring this here to become the power. So that this will be log to base 2 of y squared exponent y equals to log to base 2 of 3 plus, then this also log to base 2 of x exponent 2. Okay, now this is where I can now apply the property. Now, using the property log to base a of pq, which will be equals to the sum of the logarithms of the two separate quantities. So which means this addition, the sum of these two logs, can be expressed as log to base 2 of the product of 3 and x squared. So this will be log to base 2 of y raised to the 4th power. 2 times 2 is 4. This will be equals to log to base 2 of 3 times x squared. So we can, this will reduce to y exponent 4 equals to 3x squared. I just need to explain all of this. It's very important. It shouldn't be more than two lines. Okay, so this is our equation 3. Using equation 1 to write equation 3. So now from equation 2, we have in equation 2 is 3 exponent y equals to 9 exponent x. Okay, 9 can be written in terms of base 3 to be 3 raised to the power of 2. So this will be 3 exponent y equals to 3 raised to the 2nd power multiplied by x, and that will be 3 raised to the power of 2x. So that equation 4, okay, can now be y equals to 2x, and that is equation 4. That's equation 4. So what I will do now is I'm going to put 2x into equation 3 as y, okay? Put 2x into equation 3 as y. We have y raised to the power of 4 equals to 3x squared. This is equation 3. Okay, now y is equals to 2x. So this will be 2x, okay, raised to the 4th power equals to 3x squared. 2x raised to the 4th power will be 16. That will be 16. So this will be 16x raised to the 4th power equals to 3x squared. Okay, now I'm going to bring this here so that we can have 16x to the 4th power minus 3x squared equals to 0. Now I can factor out x raised to the power of 2. Okay, in this case, so we have x raised to the power of 2 parenthesis 16x squared minus 3 equals to 0. Okay, x squared equals to 0, which implies that x equals to 0. Of course, this will be rejected. That will be rejected. X equals to 0 is not a solution. Okay, then it's not a solution. Apart from this, it is not a solution. All right, so then we have 16x squared minus 3 equals to 0, so that 16x will be equals to 3. Dividing both sides by 16, x squared will be equals to 3 over 16. So that if I take the square root of x squared and take the square root of 3 over 16. This is plus or minus. So we have x to be equals to plus or minus radical 3 over 4. Now, if we check the domain of this, if we check the domain, we see that x will be greater than 0. So it means that negative radical 3 over 4 is not a solution as well. So which means that is x equals to radical 3 over 4 is a valid solution. Is a valid solution. Okay? Because x is greater than 0. Even y must be greater than 0. Okay, as far as this question is concerned. All right, so let's solve for y. Now, to solve for y, now to calculate y, now I'm going to put root 3 over 4 into equation 4. Okay, equation 4 as x. And we have equation 4 to be y equals to 2x. So which means that y will be equals to 2 multiplied by the value of x. That is, I'm using the positive value of x, which is root 3 over 4. Okay, that's root 3 over 4. So that this will be y equals to radical 3 over 2. So therefore, our solution will be, we have x to be radical 3 over 4, okay, and then we have y to be radical 3 over 2. So this is the solution to the simultaneous equation. The noblest pleasure is the joy of understanding. Bye-bye.